Greetings developers, this is Manfred Bergman. I'd like to follow up this time on the introduction of the cl-gserver Common Lisp library. So the last time we were talking about the agent, which is part of this library. And the agent, if we can recall shortly, is a very specific facility in order to maintain state. So the agent maintains state for you. Basically, it runs its own messaging queue, and it runs its own thread that operates on this messaging queue. And so, in a multi-threaded environment, multiple threads are basically so state changes which are encapsulated in this agent are synchronized or serialized through this message queue, so that only one thread, the thread that maintains this message queue, actually changes the state of the agent, or of the state that the agent represents. And today I'd like to talk a little bit more about another facility which is part of this library, which is the actor. So both the actor and the agent are based on, they share the same principles, or they share the same base implementations, basically. So also the actor is message driven and asynchronous partly, but they share the same basics. So to speak, only that the agent has a very specific interface, where the actor is more generic and can be adapted to whichever use case you need. So actors are actually pretty old. So they were thought about, or the concepts were thought about and invented, I think already in 1973 or around that time. And one of the well-known runtimes or virtual machines that use actors is, for example, Erlang or also Elixir, which also runs on the Erlang virtual machine. But the gen server of Erlang is basically was taken as an example to create the G-server of this library. And the actor is actually a subclass of this G-server, and it only changes a little bit the terminology, and it simplifies a few things. Yeah, but I think I can do more explanation while going ahead and do some coding. So the first thing I would like to do is to create a package where we work in dev package actor intro. Let's call it actor intro. So we use CL, we use cl-gserver. Oh yeah, so that reminds me, I have to first load the library. Quick load cl-gserver. Right, and what we also need is Alexandria. Yes, okay. So let's again create a package, dev package actor intro. cl-gserver, and what we use today is the actor sub package. So we use the actor sub package, and we also use the future. Yes, and we might also need Alexandria, but also, yeah, let's use the full package, Alexandria. Okay, good. in package actor intro. Good. So to create an actor, there's a function called make actor. Make actor. It takes a few key arguments like the name, the state, and a receive function lambda, and then after init function lambda. So the name should be clear. If you don't specify a name, there's one created for you, which is internally using the Gensum facility to have a unique name. So every actor should have a unique name eventually, and then the state. So the state, let's call this echo actor because we want to create an echo actor. The state can be, I don't know, it can be anything that you want to have as state of this actor, or it can be anything that the actor should encapsulate as state that should be maintained through this thread that operates on the state. So in this case here, what could be the state? So I want to count the number of messages that have been passed through. Yeah. Okay. So let's take a 0 here, and then we need to specify a receive function, receive fun. And this receive function is basically the message handler that you have to implement, right? So the message handler has a few arguments. It is self as the instance of the actor itself, then the message, and then the state. So all those three arguments or those three parameters are passed into this lambda where you can then do something with it. So one part of this interface. Let's say it differently. So what this receive function must return, so it must return something. What this receive function must return is a cons, and it must return a cons of the car part is something that is returned to the sender. So since we are creating a echo actor, we just return the message as we received it, right? So we just so we put the message as the car part, and then I want to increment the state incf the state. I'm not sure what this returns, but I hope it returns the new state. I'm not sure. Well, we should check it. So this cons must have. So the car part of this cons is something that is actually returned to the caller, right? So in case you make an ask operation on this actor where the caller expects something to get back, then this car part is the thing that is that is sent back to the caller. And the second part of this cons, the coder, is will be the new state. So there's some logic. So there's some logic that takes both of those components and works with it. So the left part is returned, and the right part is used to update the actor state as such, right? And that's actually all we need here. So when I press return, I will have a new actor, but the problem is I can't use it because it is an anonymous actor. So let's put it in a parameter. Meta echo echo, yes. Okay. So now we actually created two actors, but the first one I hope will get removed anyway. So there's also some logging going on. If you don't want the logging, you can switch it off by log for CL. You use log config and then use warn, and you will only get warn messages. But we also already see here that this make actor function creates an actor with an unbounded queue. So you can see here the message box queue is an unbounded queue. So basically so this actor basically accepts an unlimited number of messages. And we will see later how you can change that. So but this make actor function can only create actors that have an unbounded queue. Anyway, so let's send something to this actor. So when we make a send, so you can talk in two ways to this actor. You can either send it as just a message and don't expect anything in return. This is send, which is asynchronous, right? So send echo something T. So this only responds with T. So we don't know actually if, well, yeah, it only responds with T. But if we want to have a result, we need to ask it echo something. And the way we have implemented this actor is that it sends back to us what we have sent to it, right? And in this case it should be the something string. So let me now inspect the actor. So we see here it is a simple actor. This is the name. It is running. It is in state running, and the state here we see is 2, because we have sent 2 messages to it. It was first the send and then the ask. So this incf actually works okay. We have incremented the state, and well, the message box actually also counts the number of processed messages, which is also 2 in this case. But there's one thing that is important to talk about. The ask operation is a synchronous operation. So since we got this result back, there is something that explicitly waits and blocks until the response, or until the actor actually has processed the message and generated a response, which is this receive function, right? So there's something internally that blocks until this message has been processed so that a response can be returned. So if this is not wanted, there is an async ask. This is still pretty new, and it's not part yet of the Quick Lisp distribution, I think, but it's already committed and should be available in Quick Lisp with the next release of Quick Lisp. So we can do we can store the result of this async ask in a parameter just so that we can. I just want to show you what we can do with the future. So we store it somewhere so that we can work with it. So the async ask works the same way as the ask, only that it returns immediately. And what we receive is a future. and we can talk to this future. We can ask it if it is complete, and it should be completed by now because this is a very fast operation here, so it should already be completed, and it says T for yes, it is completed. And then we can actually also get the result of this future, which is in this case something. So this is what has been returned from this actor. But get result will respond with a not ready, I believe. So it will respond with not ready when the future is not completed yet. So how can we do something in response to completing the future? And that is when we have to add an uncompleted handler. So we can set up an uncompleted handler which accepts a lambda, and the parameter of this lambda is the result, or actually the promise if you want, the promise of the future. And and what we can do here is, for example, so you could do all sorts of things here, right? So this is an asynchronous operation, and when the future is completed, you can do something with the result of this processing of the message. So but here I just want to print the message. Result. Okay. So in this case, since the future is already completed, the lambda function will also be called immediately, and what we get here is the side effect of result something. But what we also see here is the underlying code, or the underlying framework which is used for the future implementation of this async ask is the Blackbird promise library. So I was thinking, do I invent something on my own, or do I use something which is already available? And I thought, okay, so I think it's better to use a library, a future or a promise library which is already available. The problem I have with the Blackbird library is the terminology of a few things. So so what actually should be a future is called a promise, and some of the other functions, for example, this uncompleted is actually in the Blackbird library called attach, which I don't like very much, to be honest. But anyway, I didn't want to invent something my own, so I just created a very thin wrapper on top of this, which wraps the promise, and I call it future, and I call this uncompleted handler uncompleted, and so forth. But otherwise, it's just in the background, it's the Blackbird promise library. So this was for the simplest case, create a simple actor, right? So you can use the make actor to create a simple actor. When you want to create something more sophisticated, and you want to actually have a subclass, a dedicated subclass for this, then I will show you now how this works. Let's create a new buffer. I want the REPL also here on this side. So, and the way this works is that you create a new class. You create a new class and call this class, let's make a Factorial Actor. the base class is actor, and here you can specify additional slots. I don't need additional slots, so this is okay for me. So let's compile this and let me check if it is available here. Describe Factorial Actor. Okay, good. So, and the only thing you have to implement is a method called receive. Receive, and it also has 3 parameters. It's the actor instance itself, which I usually call self, and then we have the message and the current state. So this is exactly the same as we have done here on this side with self, message, and state. Because this lambda actually represents this receive function. And so what do we create here? So let's create a factorial actor that when we send a message, which is so I want to send a message which is a what could it be? Should it be a cons or what? Yeah. So let's create a message that is a cons, and we differentiate on the car of the message whether it is fuck, and then the number, or let's say, so the second part of this cons must be the number where that we want to calculate as a factorial. So the cutter of this cons will be the number. And let me paste in a factorial function I have already available here. It's based on reduce, and it uses iota, which is a pretty elegant. So I didn't come up with this method myself, but I think it's a very elegant way of calculating a factorial, although it might not be the fastest one, but it is quite elegant, I think, using reduce. So the cutter of the message is so the cutter of the message is the number we want to calculate the factorial from. Right? So let's see if unused variable current state. Okay, so to get rid of the warning, we can do this. Okay, so now when we want to create an actor of this, then we need to use the make instance, and then specify the fuck actor. And here we have we can specify yeah, you see in the bottom here, I hope you can see it at least, all the available parameters we can give it. And one is the state, which is required, so you have to specify the state. The name is optional, which defaults to a Gensim GS dash name, and we also have to specify the max queue size. I'm not sure, do we have to specify it actually? I'm not certain. I think it's not necessary to specify it. So when we omit it, it automatically creates an unbounded queue. But this is what we talked about earlier. So you can, in certain circumstances, you might want to have a bounded queue. For example, to have more control over the memory consumption of your message queue or whatever. And then you can create a queue of a message queue that only has, I don't know, 100 or 1,000. That only can host 1,000 messages in this queue. And the mailbox or the message box with a bounded queue automatically implements back pressuring, for example, when the queue size exceeded a certain threshold. So this is all implemented in the cl-gserver library. But let's give it a name. Factorial Actor. And I'm not sure if I need to specify a state, but let's use a state of 0, and then we should be good. Let me check. Yes, Factorial Actor. Now let's see. Let's ask the actor, fac actor, and send it a cons with, we need this fac, and we need a number. Let's take 5. Okay. So here we received a handler error. So a handler error is returned. So there's internally some error handling going on, and if something is not right, you will receive an error, a handler error. And in this case, the handle call result is no cons. So what this means is that the receive function must return something, and so it actually must return a cons. So in case we have we received this fac message, then the first part which I want to be returned to the sender is the calculated factorial number, and the second part can be anything. I don't know. I can return the current state, or I can also return nil if I don't care for the state of this actor. So in this case, this actor is more or less only used for doing computation stuff. So it's a computational unit. It does some computation for me, and in this case it doesn't necessarily need a state, so you can just call this is not ignored. Alright, so let's take this out again. Good. And now when we do this again, we get returned the 120, which is the factorial of 5. So this is correct. Now the problem is the larger the numbers for this factorial, the larger is the blocking of this ask operation. So in this case, I would want to have an async operation. So I register an uncompleted handler, and the future of this uncompleted handler is actually the async ask operation. Fac actor, and let's create a larger number like 100,000. And then what should happen when this was calculated? I would say I just want to, so we could trigger some other operation now, like calling another actor, or storing this on a database, or whatever you want to do. So in this case, I just want to, I don't actually want to display the number, because displaying the number, this large number, on the REPL console is not such a good idea. So I just want to print result ready. Okay, lambda result ready, on completed, go for it. So we only got the return of, so what this uncompleted returns is basically the future or lambda. But when we press no, okay, so I made a mistake here. So this means nothing. So I want to have a side effect here, and I need to print this, right? I need to print this to the console, otherwise nothing will happen. Format. So, but we should see something on the console now, don't we? Async Ask, consfac. Wait a second. Now it is. Now here it is. Okay. So it took a while to, it took a little bit to calculate the factorial for 100,000. So here we have now the printout as a side effect of the uncompleted handler. Good. Now that was pretty much about it, what I wanted to show you. So the library is still in a very simple state, and there might be some, so I'm not entirely certain if all the interfaces will stay as is. But what I want to additionally implement in the relatively near future is that it should be possible to change the behavior of an actor. Like, for example, that you can change the message handling mechanism inside this receive function depending on certain occurrences. So, for example, you can, so that you can change the change a message handler depending on a message that is received. So you can switch behavior. What I also want to do is to have a thread pool that is used by the actors to process their messages. Because right now every actor maintains its own thread for the message queue. Now for a few hundred maybe actors this might still work okay, but since those are not Erlang green threads, or Erlang doesn't really have green threads, but since those are, so since the Lisp threads are relatively expensive operating system threads, creating a few hundred or even a few thousand or millions is not really possible, so this won't work. And so I would like to have a thread pool as part of maybe an actor system kind of thing, where each actor can take a free thread from this thread pool to operate on a message, and then give the thread back for some other handler or for some other actor, so that actors basically share a thread pool, a thread or a message dispatcher pool of a configurable number of threads. So what I also want to do is to implement more of an actor system, where you don't create actors like this manually by make actor or so, but you can make the actor system create an actor for you that you can then work with, and the actor system takes care, registers the actor and takes care of some of the internals, internal registration stuff, administration stuff for you. And then what we can also then do is to also add supervision of actor trees, for example, and stuff like that. But yeah, so it's still a little bit work in progress, but it works reliably so far. And yeah, so that was it. I hope you enjoyed it. So yeah, see you next time. Bye.